Hello everyone. So in this pre-lecture tutorial, I'm going to give an example of how we relate enthalpy of reaction to the stoichiometry of a chemical reaction. And the reason we need to do this is because, if you recall, the energy content of a substance happens to be an extensive property, meaning it depends on the amount of material present. And so since enthalpy is a reflection of the energy content of a substance, then we need to make sure to take that into consideration when we deal with quantitative aspects of enthalpy. And so let's go ahead and work through an example together. We'll talk in greater detail in class related to how enthalpy is defined, how it ties into internal energy, which we defined in class today, and also in terms of relating it to terms such as exothermic or endothermic, which is actually where we left off in class before we had to break for the day. So here I have this example problem on the screen where I'm being shown the fermentation reaction for glucose. Now, note that I'm being told that the enthalpy of the reaction is negative 67 kilojoules. Now, as we learned in class, when thermodynamic quantities are given a negative sign, that means that is a loss by the system, and also a gain by the surroundings. Okay, so if this heat is being lost by the system, then that means, and to answer this first question, it means that this is an exothermic reaction, because basically the system is releasing heat to the surroundings. But the second part of the question is asking me to calculate the energy released when 250 grams of glucose ferment. And so what I need to do is note that enthalpies of reaction like this are typically expressed per what I'll term mole of reaction. And what that means is this is the heat that's released when the reaction proceeds exactly as written with these stoichiometric coefficients in place. And so if I'm looking at the amount of glucose involved in releasing these 67 kilojoules of heat to the surroundings, that reflects 1 mole of glucose reacting. But notice that I'm given a different amount that isn't 1 mole. I'm given 250 grams of glucose. And so if I'm going to figure out how much heat is released when I have 250 grams of glucose as opposed to 1 mole of glucose reacting, the very first thing I'm going to need to do is convert these grams of glucose to moles of glucose. So that means I'm going to have to determine the molar mass of glucose. Again, I'll leave it to you to confirm, but basically that should be 180.2 grams of glucose per 1 mole of glucose. Okay? Now that I've done that, now I can relate back to the balanced chemical equation and also the enthalpy of reaction that's provided. According to this information, for every 1 mole of glucose that reacts, 67 kilojoules of heat are released. So if I go ahead and do this math, I take 250 grams, divide by 180.2, and multiply by 67, I get 93 kilojoules if I round to two significant figures. Because this represents a release of heat by the system to the surroundings, then I should include a negative sign to show that it's a loss of heat by the system. Now, if this had been any of the other species involved in the reaction, either the carbon dioxide or the ethanol, then I would have to go and use that stoichiometric coefficient instead. And so this stoichiometric coefficient down here in the denominator, or the final conversion factor, would have changed. So go ahead and work on the follow-up assignment. It's a similar problem to this. We'll be doing some additional examples of this in class. Again, if there are any questions related to the beginning of Chapter 5 or any of this material in the pre-lecture tutorial, again, by all means, feel free to email or to bring up those questions in class. Okay, have a good night, and I'll see you tomorrow.